Hello class, in today's video we're going to be looking at graphing straight lines. The learning intention of this video is we're going to understand what it means for a point to lie on a line, both graphically as well as algebraically. We're going to understand that straight lines have a constant gradient, to know how to determine the gradient of a line from its equation and use it and a point to sketch its graph, to be able to find the x-intercepts of a linear graph and use them to sketch the graph. And lastly, we're going to be able to sketch straight lines with only one single intercept, okay? The first thing I want to talk about is what is a linear equation, okay? So a linear equation is an equation that contains one or two variables, okay? Remember, the word variables just means letters. So for instance, an example of one would be y is equal to 2x plus 5. This is an example of a linear equation, and all linear equations have a variable that are raised to a power of 1. So that means in this case, x is going to have it to the power of 1, and that's evident over here in this example as well. What happens when we actually sketch a linear equation? What will happen is that it will produce a straight line, which is why this produces a linear graph in this case over here. Now, when you do sketch the graph of a linear equation, what you'll see is you'll actually have three important features, okay? The first thing is that you're going to have an x-intercept, and the x-intercept just means where along the x-axis does it actually cross through. So in this case of here, this straight line, this blue straight line, it crosses the x-axis at x is equal to -1. So that is where your x-intercept is going to be, okay? Now, what I do want to draw your attention to is that for all graphs, the y value is going to equal to 0 at the x-intercept, okay? So in this case over here, this is your y-axis. Note at this position over here, the y value along that vertical scale is equal to 0, okay? Because we know that at this point over here, which is the origin, that's where 0 is equal to, so y is equal to 0 at the x-intercept. Now, the y-intercept is just the opposite of this, okay? So the y-intercept is the position along the y-axis where the straight line passes through. So in this example of here, your y-intercept is equal to +1. The y-intercept for this example down below is equal to -2, okay? And at that position over there, the x-coordinate, so remember the x is the horizontal, the x-coordinate at that position is going to equal to 0. Now, one thing that I do want to mention, particularly for future lessons, it's going to be more critical, even so in VCE, but when you do actually sketch a linear graph, or all graphs for that matter, you actually need to state the x and y intercepts in this coordinate form, okay? So instead of writing like y int is equal to, let's say 6, and x-intercept is equal to -4. This is how you generally use marks, because we generally express all the intercepts as a coordinate form, okay? So intercepts must always be written in coordinates. And the last feature that I want to talk about is what do I mean by the word gradient? And the word gradient essentially just means the steepness of a straight line. So in this example over here, the slope or the gradient in this example is equal to 2, because 2 divided by 1 is equal to 2. And notice that the slope, the slope for a straight line is going to be constant, okay? So it's always going to be 2 regardless. Whereas if you had a graph that was a curve in this case over here, notice that the steepness of the graph will gradually decrease, and then it will be in the opposite direction, okay? So that's what I mean by the word gradient. Now, what you need to understand is that any linear equation can be represented or expressed in two different forms, okay? So the first form that we're going to be looking at is the slope-intercept form. So as given by its name, the slope-intercept form pretty much tells you what the slope is, so what is the gradient, that's represented by the letter m, as well as one of the intercepts, and we'll go into a bit more detail later on. Alternatively, another way that you could actually represent or express a straight line is by writing it in the standard form, okay? So this over here is what the standard form looks like. Now, you're probably asking what's the point of having two different forms? Well, there are pros and cons for each of the forms, and we'll shortly touch on that later on. But just to give you an example of what I mean by the slope-intercept form versus the standard form, I've got these two examples down below. Now, you may assume on first glance that these two linear equations are actually different, and they may actually produce two different lines, okay? That's a safe assumption. However, what I'm going to try to show you right now is that you can actually convert from one form to another form, and if you actually rearrange the standard form to make y the subject, you will actually see that these two equations are actually identical to one another, okay? As I briefly mentioned earlier on, Both each of these forms over here have certain advantages and disadvantages over the other, and I'm just going to provide you a brief overview of what these advantages are. So in this case here, for the slope-intercept form, the advantages of that is that it's able to readily give you what the gradient is and what the y-intercept is without doing really any calculations at all. Whereas for the standard form, you're readily able to actually find out what the x and y-intercepts are with very minimal calculations, okay? Now, although that the slope-intercept form can give you the y-intercept and the gradient, you can still find out what your x-intercept is. I'm not saying that you can't find out what your x-intercept is. It's just going to take you 1 or 2 extra steps for you to do the calculations in order for you to find out what the x-intercept is. Similarly, for the standard form, you can also find out what is the gradient. You just need to do 1 or 2 extra steps in order for you to actually find that, okay? So it's just a bit more time consuming, but these are the respective advantages for each of these two forms over here. What I'm going to talk about now is the linear equations that's represented in the slope-intercept form, aka the y equals mx plus c form. So the slope-intercept form is a specific form of a linear equation. It has the general structure, y equals mx plus c. And what the letter m represents is it represents the gradient, or refers to the steepness of the actual straight line, whereas the letter c corresponds to the actual y-intercept, okay? And both these m and c, they correspond to values. So therefore, a large m value would mean that it's very steep, whereas a small m value, okay, so it's a number that's between 0 and 1, like 0.2, that would indicate that it's not very steep at all. So I've got an example over here, so just to help you understand and interpret the actual general equation of a straight line expressed in this form. So if you've got an equation like this, y is equal to 2x, in this case over here, the number or the coefficient in front of x is the gradient. So in this case over here, the gradient is 2. And what I do need you to understand is that gradient is the same thing as rise over run. Now, in this case over here, your gradient is equal to 2, and you can write 2 expressed as a fraction, which means in this case over here, it's rising by 2, and it's going horizontally by 1. That's the rate in this case. So in this case over here, starting from your y-intercept, which is what this value here is c, you're going up 2 units for every 1 unit you move to the right, okay? So therefore, your next coordinate is going to be right over there. All right, guys, just some basic testing understanding. So what I want you to do right now is I want you to state the gradients for each of these examples below. If you guys have done this successfully, for the very first one, part A, you should have got that as +5. For part B, it's tried to trick you around by rearranging the order a bit. But in this case, your gradient is going to equal to -4. Remember, it's always going to be the coefficient in front of the letter x, okay? All right, guys, if you guys have done this question successfully, the y-intercept for this particular question is going to be equal to part B, or option B. We know that the y-intercept over here is going to be this one over here, so y is equal to -11. But remember, when you're trying to write this in the coordinates form, you always write the x letter first, followed by the y coordinate. So therefore, that's why it's going to be 0 and -11, okay? Remember, the x coordinate is always 0 along the y-intercept. And for the very last question over here, if you guys have done this successfully, the answer for this one is going to be 0, okay? Now, you're probably thinking, why would this be the case? Well, this equation over here kind of looks very similar to this over here. I'm going to rewrite this in the slope-intercept form to see how is it actually similar. I could write it like this, okay? So that's pretty much the exact same thing, but I've written this in the slope-intercept form. In this case, your value of c is equal to 0, so therefore this indicates that your y-intercept is equal to 0, so therefore A is going to be the correct answer. What we're going to look at next is to decide whether a particular coordinate lies on the straight line. So there are actually 2 methods that you could actually use to determine whether a coordinate lies on a straight line. The first one is graphical, and the second method is by determining algebraically, okay? The first method is pretty straightforward. So if you want to see whether a particular coordinate lies along the straight line, you just plot that along the Cartesian plane and just see whether it actually sits on the line. So therefore, if this is my example over here, determine does -1 and -1 lie on the line represented by this particular equation over here. So if I also plot the coordinate, that's where -1 lies. And in this case over here, you can clearly see that this coordinate lies along this straight line. So therefore, yes. Now, how would you do this algebraically? Okay, so in order to actually determine whether something is algebraically, you need to understand that any coordinates that are found along a straight line are therefore solutions that satisfy that particular given equation, okay? So in order for you to determine whether a coordinate lies on a line algebraically, what we need to do is you need to substitute, meaning plug in those sets of coordinates into that particular equation and see whether it produces a true statement or not. So let's look at an example over here. So I'm going to show you using the exact same equation, the exact same coordinates before, how to do this algebraically. So what I'm going to do is I'm going to substitute this particular coordinate in. Remember that the first value here represents your x value. This represents your y value. So wherever you see x, I'm going to sub in -1. Wherever I see y, I'm going to sub in -1 also. So if I do that, this is what I would have. And what we're going to do is we're going to pretty much expand and then just collect things just to shorten things down. So therefore, if I'm multiplying this, -1 is equal to -2 plus 1. Now what I'm going to be doing is I'm just going to condense this. So therefore, -1 is equal to -1. Does this produce a true statement? Is -1 equal to -1? Yes, it is. So therefore, in this case, because it does, therefore this coordinate does lie along the equation over here. What I want you to do now is I want you to do the exact same thing, refer to the example before to determine whether this particular coordinate lies along this particular equation over here. Give yourself 1 minute and then compare your answers with my answers. If you guys have done this successfully, what you have done is you would have substituted this coordinate into the equation. So therefore, remember, this corresponds to your x value. This corresponds to your y value. What I'm going to do now is I'm just going to simplify. So 3 times -1 is -3. 3 times 4 is 12. Now I'm just going to condense the left-hand side of the equation. What is -3 plus 12? Well, that gives you -9, but you can clearly see that -9 is not the exact same number as 2. So therefore, because this does not produce a true statement, therefore this coordinate is not actually found on the line at all. Now, in order for you to actually draw a straight line graph, all you really need to know is just 2 coordinates and then just draw a line that runs in between those 2 coordinates. And what I'm going to show you now is I'm going to show you 2 methods that you could actually use to sketch any given linear equation, okay? So the first method I'm going to show you is how do you do this through the gradient intercept method. And as the name implies, you're going to be using the gradient and one of the intercepts to actually sketch that out. So the gradient intercept method involves plotting the y-intercept, okay? So not the x-intercept, just the y-intercept and another coordinate using the actual gradient, okay? So since the gradient is the same thing as rise over run, what we're going to do is we're going to express the gradient in this form, so in this fractional form, and then we're going to find the position of another coordinate starting from the y-intercept. So this is my equation over here. So I've got the equation y is equal to 2x plus 1. What I'm going to show you right now is how do we actually graph this using the y-intercept as well as the gradient. In this case over here, we know that the gradient is equal to 2, right? Because that's the coefficient in front of x. Now, what I'm going to do is I'm going to represent that gradient in this fraction form just to see how much it rises and how much it runs. In this case over here, you'd agree with me that 2 can be written as 2 over 1 as a fraction. So therefore, we can say that you're going to be rising 2 units for every 1 unit you run horizontally. The y-intercept in this case over here is going to equal to +1 because that's reflected by this value over here. So I'm going to plot firstly the y-intercept along my Cartesian plane. Now what I'm going to be doing is I'm going to use this rate over here to find the position of another coordinate, and once I've got this y-intercept as well as another coordinate, then I can easily draw a straight line by connecting those 2 dots together. So in this case over here, it's saying that I need to rise by 2. So I'm going to go up 2, okay? And then I'm going to move on 1 unit to the right because the right is the positive side, okay? So therefore, if I move 1 side to the right, therefore that's the position of my coordinate over here. And that coordinate reflects to position 1, 3. And now once I've found out that coordinate, I just draw a line in between these 2 dots. And therefore, this is pretty much the graph for this particular equation over here, okay, guys? And note again, when I'm drawing a graph, I actually need to state what the coordinates are in these coordinate forms over here, okay? And make sure you are also labeling your intercepts as well. Your axis, sorry. I'm going to show you another example over here, but in this example over here, notice that your equation is now expressed in the standard form, okay? So the question wants you to find the gradient and the y-intercept, and then based on this information, I want you to sketch the graph. So again, what I want to be doing is, because the standard form doesn't actually give you the gradient, we need to convert this into the slope intercept form for it to give us the gradient. So essentially solve for y, get y by itself, okay? So in order to do that, what I'm going to be doing is I'm going to remove the 2x by subtracting 2x on both sides, okay? And if I subtract 2x on both sides, these are inverses, so they get rid of each other. So therefore, my equation is going to be simplified to 3y is equal to negative 2x plus 3. And now because I've got a 3 in front of y, I'm going to kick off the coefficient by dividing both sides of the equation by 3. And if I divide both sides by 3, well, 3 divided by 3 is equal to 1, so that cancels each other out. Negative 2x divided by 3, well, you can't really simplify this any further, so I'm going to leave that as it is. But 3 divided by 3 is going to equal to positive 1. So therefore, my equation, when I rearranged it, is going to equal to y is equal to negative 2x on 3 plus 1. And now this is in the slope-intercept form. Based on this, I can readily say that my gradient is equal to negative 2 and 3, and that my y-intercept is going to equal to 1. And I've written the y-intercept in the coordinate form. So what I'm going to do now is using the y-intercept as well as the gradient, I am going to graph this. So firstly, I'm going to plot the y-intercept as shown over here. And now my gradient says I'm going negative 2 units, okay? So in this case, because rise means going up, and negative means you're going the opposite direction. So instead of going up, I'm actually going down 2 units, okay? As shown over here. So I'm going 1, 2. Now I need to run 3 units horizontally, okay? So because that's a positive 3 over here, I'm going to be moving to the right-hand side. So I'm going to be moving 3 units like so. And therefore, my new coordinate is going to be 3 and negative 1. And now what I'm doing is I'm going to connect these 2 dots together. And therefore, this is going to be my graph over here. Now, over here on the slide over here, I just wanted to show you again is that graphing via the gradient-intercept method for equations in the standard form is a bit more time consuming, as I showed you just in that example over there, because what you had to do was that you had to convert it in the slope-intercept form, and based off that, you can therefore have your gradient as well as a y-intercept for you to actually sketch it, okay? So this gradient-intercept form is not really ideal for the standard form. It's a lot better when it's already in the slope-intercept form because you've got the gradient there. What I want to show you is another way over you to actually sketch, and this method over here is probably the more popular method, and it's the method that I prefer personally, but you actually need to know both methods because an exam question might specifically ask you to do in a certain type of method, okay? So in this case over here, a linear graph can be sketched by drawing a line between the x and y intercepts, okay? So as long as you've got 2 coordinates, which is your x and y intercepts, you can therefore draw a straight line in between. In order for you to solve your x-intercepts, you just need to sub y is equal to 0 and then transpose if it's necessary. Similarly, if you want to find out what the y-intercept is, then you sub in x is equal to 0 and then transpose if necessary, okay? I'm now going to show you how you can actually find the x and y intercepts for equations that are both expressed in the slope intercept form as well as the standard form, okay? Now, what I'm going to do is I'm going to color code my solution. So therefore, if I was trying to find out the x intercept, I'm going to write that in red. And to show my y intercepts, I'm going to show that in blue, okay? Just so you can actually see. Now, to find out the x-intercept, you need to sub in y is equal to 0. So therefore, I've subbed y is equal to 0 as shown here. And now what I'm going to do is I'm just going to rearrange the equation so that I can find the value of x, okay, when y is equal to 0. So therefore, I'm going to move x to the left-hand side by subtracting both sides of the equation by 2x. So therefore, these are inverses, so they cancel each other out. So therefore, I'm going to have negative 2x is equal to negative 8. Divide both sides by negative 2. X is therefore equal to 4, okay? Now, I'm going to find the y-intercept by substituting x is equal to 0. But you can tell without even doing any calculation. Remember, that was your y-intercept. But to show the working out, to support that, 2 times 0 is equal to 0. 0 take away 8 is therefore equal to negative 8. So therefore, that's your y-intercept. Now, if once I've got these 2 coordinates, you need to plot that along a Cartesian plane. And make sure, again, when you are sketching, you do need to state your intercepts in coordinate form. So you have to write it in a manner similar to what I've done over here. All right, for part B, this is in a standard form. And remember, I said earlier on during the lesson, anything represented in the standard form, it's so easy for you to find both the x and y intercepts with very minimal working out, okay? So in this case over here, to find out the x-intercept, I'm going to follow the exact same procedure. Sub y is equal to 0. 2 times 0 is equal to 0, so I'm going to ignore that. So that's the beauty of the standard formula. By substituting like x or y is equal to 0, you pretty much cancel one of the terms, so it makes the calculation a lot more easier. So therefore, we're left with negative 3, x is equal to 6, x is therefore equal to negative 2. And to find out the y-intercept, you can let x is equal to 0. Any number multiplied by 0 is equal to 0, so you pretty much ignore that. So negative 2y is equal to 6. Divide both sides by negative 2, y-intercept is equal to negative 3, and therefore draw a line between these two coordinates over here. And again, you need to actually write this in coordinate form, otherwise you lose like a mark also every single time for both your year 12 exams, and that's just tilting. Okay, now in that example again, I've just showed you pretty much that if you're trying to find the x and y intercepts and you're graphing it by using the x and y intercepts, it's a lot more easier if you did it if the equation was already expressed in the standard form. But as I've shown you before, when it's in the slope intercept form, then this is going to take a bit more longer because obviously you have to rearrange. So this just takes one extra step, but obviously you can find the x-intercepts for both forms, okay? What I want to get you to do right now is I'm going to get you to find the x and y intercepts for the following linear equations. So give yourself 3 minutes to answer part A and B, and then compare your answers with my answers. If you guys have done this successfully, then for the first part here, your x-intercept should be equal to 2. So make sure that you've written this in coordinate form, okay? So it would be 2, 0. And the y-intercept in this case is going to equal to negative 4. For part B, your x-intercept should be equal to negative 5, and your y-intercept should be equal to negative 2. Now, the last part of today's lesson is looking at straight lines that only have one particular intercept, okay? And this is something I'm just going to briefly go over because it doesn't really require any explanation, really. So there are 3 types of examples that just have one particular intercept, okay? So in my first example, your equations might have a similar structure or formula to this one over here. So y is equal to a, where a represents any number in this case. So in the example over here, y is equal to 2. In these types of straight lines, this means regardless of what your x value is, your y value is always going to equal 2. That's what this particular equation means, okay? So regardless of whether x is equal to negative 5 or whether x is equal to positive 1, even though these x values are different, your y value is still going to equal to positive 2. That's the vertical value, okay? The second example over here is pretty much the opposite of that, okay? So x is equal to a, where a represents any value. So in this case of here, if my equation was x is equal to negative 3, so negative 3 is over here, I draw a vertical line this time, because what this means is regardless of what my y value is, whether it's positive 8 or even negative 2, the x value is always going to remain the same. X is always going to equal to negative 3, okay? Because if I write that coordinate, that's negative 3, negative 3, negative 8, and that's also over here. This is going to be negative 3, negative 2. Doesn't matter what y value it is, the x value always stays the same. And for my last example, it's expressed in the form of y is equal to ax, where a represents any number. So in the example down below, I've got negative half x. And in this case over here, when it's written in this similar structure, notice that both your x-intercept and y-intercept pretty much occurs at the origin. So that's the only thing that I need you guys to identify for each of these 3 examples over here. In order for you guys to strengthen your understanding, I highly recommend you answers all of question 6, all of question 3, as well as all of question 4. Now, I know that for question 3 as well as question 4, they both ask you to actually sketch the graph, and this is going to be time consuming, but unfortunately, you need to actually get a lot of practice with drawing. When you are actually sketching the graphs for all of these, make sure that you are including and stating what the x and y intercepts are by writing them in terms of the coordinates, okay? Questions 5 as well as question 6 I need you to do, but in this case of here, they also require you to sketch the graph. I know that this is going to be too time consuming now, so I'm actually happy for you guys to only complete the first column, and for question 6 just to complete the first 2 columns as well. Question 8 would be a really good question for you to do. Now, the reason why I recommend to do this question is because that there are a lot of exam questions that they often use this particular scenario here where you've got a tank of water and it's kind of leaking out. So I highly recommend you have a try at this type of question. This is pretty much the end of today's video. Hopefully you guys are able to meet all of the success criteria. Thank you for watching. I'll see you guys again in the next video. Bye.